Let's do elliptical orbits and conservation of momentum. Conservation of momentum states that if the net torque is equal to 0, the angular momentum will remain constant. So let's check an elliptical orbit. We are going to consider the smaller object at 3 different positions as shown, A, B and C. The distances are mentioned there, RA, RB and RC, and there will be forces of gravity acting at each position A, B and C. Now the torque for Fg at each point A, B and C will be equal to 0. The reason being the forces which pass through the axis have no torque. That means the net torque is equal to 0. So we can apply conservation of momentum. So LA is equal to LB. Formula for LA, that is momentum, is R cross P. So we apply that. And we can check in the diagram. The velocity at A is VA and velocity at B is VB. Now angle between RA and VA at each point is 90 degree because tangent is perpendicular to the radius. We can write the momentum as linear momentum as mv. When we substitute that, the mass of the smaller object can be cancelled out from both sides. It's same. So we get the equation RAVA equal to RBVB, which from where we can conclude that velocity of the object is inversely proportional to its distance from the sun or from the object which is at one of the focus. Now based on this formula you need to solve this problem. We need to find what is Vp over Va, where P is for perigee and A is for apogee. So Vp over Va will be equal to Ra over Rp because of the formula which we just now derived. You can check, this is the arrangement of the formula. We can rearrange, substitute the values to get the answer which is required. Do not forget that the distance has to be from the center, so you have to add the radius. You have to add the radius of the earth to get the distance from the center.